The size of the fillet also generally is equal to the thickness of the material to give it the strength. And as we can see on this side here, the fillet weld is a little bit larger. Some welds may be a little bit smaller, as we can see on this side, but it still has the strength to hold the component together.
For all welding processes, safety shoes must be worn, as well as heavy drill pants, cotton shirt, overalls or a dust coat. This gives protection from sparks and molten metal. With electric arc welding, there is the added problem of ultraviolet or UV radiation. It will sunburn the skin and eyes, causing what is known as arc eye, welder's flash, corneal burns or snow blindness. It feels as if sand has been poured into the eyes. The welder's mask and thick clothing protect against UV. The most common form of welding is one with a consumable electrode made of iron, coated with flux. The welding machine used is dual purpose, both for manual metal arc welding and tungsten inert gas or TIG welding. A fillet weld is one of the basics of welding.
We're going to weld two components together. Place one on top of the other. Use the tongs to steady it. Connect the return lead. And then we'll bring it over the electrode holder.
The electrode is steel with other trace elements. These elements then replace the burnt out elements of the parent material. The flux produces the shielding gas and protects the molten weld pool from atmospheric contamination. It has certain trace elements that it places into the weld, which helps to give it strength.
Turn the machine on. Turn our welding machine on. We then select the current required. In this case here, I'm going to use around 35 amps. Then we put on our safety gear.
Protective glasses must be worn. A leather gauntlet.
This is to prevent from any sparks, and also the ultraviolet and infrared rays from penetrating the skin. The helmet.
With a dark sight window to protect the eyes.
We select our electrode. Connect that up. And now we're ready for welding.
The two pieces to be welded are tacked together to keep them in position. The arc is initiated when the electrode contacts the parent metal, so that the current starts to flow through the circuit. The electrode can then be raised above the plate surface, and the current flows across the gap, creating an electric arc with intense heat and light. The welding temperature is approximately 6,000 degrees Celsius. On a first weld pass, the electrode should have a slope of 50 degrees. Second and third passes should be between 40 and 60 degrees. The weld should have a mitre profile, which produces the strongest weld. The amount of welding required for a job varies and depends on weld procedure, standard practice, or based on experience. MMA uses the metal filler wire as a consumable electrode and an inert gas to protect the molten weld against oxidation. The flux gives off gases to prevent oxygen reacting with the weld metal. The flux then solidifies to form slag on top of the weld. Once cool, the slag can be easily chipped off. Wearing safety glasses when chipping off slag is vital. The weld produced from a single pass is clean and continuous and is approximately the same thickness as the parent metal.
MIG welding differs from manual metal arc, as manual metal arc, as the name implies, is a total manual process. The GMA or MIG process is a semi-automatic. We set up the machine and then we can just simply pull the trigger. So in other words, we just pull it up, pull the trigger, and then just point to where we're going to weld. Much easier in the physical operation of it. We insert the gas diffuser. It's on a cam action, and we lock that up. We use a pair of pliers just to nip it up, make it firm, not over tighty. Here we have the gas diffuser where the gas is going to come out and cover the arc. We place the nozzle over the gas diffuser so the gas will now flow down over the weld area.
A cutaway graphic shows the torch handle, the insert nut, the shielding gas nozzle, the contact tip, and the output nozzle face.
The gas we're using here is an argon CO2 mixture. As we can see by the colour coding, this indicates that we have argon in the cylinder. This Admiralty grey indicates that it is CO2, and the black indicates there's a slight amount of oxygen. For all GMA or MIG welding process, you would have an argon mix gas for your shielding gas. We turn on the machine to the required voltage settings and adjust the wire feed to suit for our welding application.
Inside the welding machine is a 15 kilo spool of filler rod, which is fed by rollers into the torch. The welding temperature varies between 6,000 degrees and 20,000 degrees Celsius, depending on the capacity of the machine and gas covering. MIG welding is far more efficient than stick electrode and cuts production time in half. Stick electrode is more efficient on site, whereas MIG welding is more suited to the workshop and production work. Car manufacturers use MIG welding because of its efficiency. At this VW factory in Germany, robots perform many welding tasks. Due to the automation of the factory, the MIG process is suited to repetition, producing precise, high-quality welds. MIG welding requires the operator to push weld rather than pull. The torch should be held very close to vertical and point in the direction of travel at about 80 degrees to ensure maximum use of the shielding gas. The electrode wire does not have a flux coating, and a separate shielding gas is employed to protect the weld from atmospheric gases such as nitrogen and oxygen. This eliminates slag, the residue from flux. The finished weld has formed a strong bond with the parent metals and a clean bead along the weld joint.
TIG welding, as the name implies, is tungsten inert gas welding, which now generally they call it GTA welding, with gas tungsten arc welding. We use a non-consumable electrode. This is a thorium type electrode. There's also a zirconated type of electrode for aluminium alloys. And a filler wire. This is the stainless steel filler wire that we're going to be using for our exercise. And it is a manual process where we would strike the arc and manually feed in the filler wire. This process requires a shielding gas, generally of an argon or an argon mixture with helium, depending on the arc temperature and the material that's required. TIG or GTA welding is used on primarily thin material, used on aluminium, stainless, brass.
These aluminium pipes have been welded, forming a neat and clean join. The torch has many parts to assemble.
Screw in the gas diffuser. And these holes here allow the gas to escape and around the nozzle. Then we put on the nozzle itself. This directs the gas over the arc and over the area in which you're going to be welding. Then we have the collet, which houses the tungsten electrode or non-consumable electrode, and we poke it out about 3mm, hold it there, and then we replace the backing cap or the back cap, and that locks the whole lot into place. You just tighten up firmly, not too tight, and then when we're ready to go we just press the trigger and the arc is created and we start welding. Turning the gas on, turn the power on, we turn the machine on. We now have to change it from manual arc to TIG. Once we've done this, a T is indicated in our screen. We also need to change the current setting from AC to DC. DC negative, then change our current setting to suit the work that we're going to be doing. In this case we might need to drop it down to somewhere around 50 amps.
Gloves worn are made from thin and flexible leather. Unlike the heavy gauntlet, they provide fine control during the welding.
You need to have the feel, you need to have the control. We need to be comfortable. I need to sit down, concentrating on the weld.
The torch releases the gas first and the arc strikes. Care has to be taken when tacking so that the metal doesn't distort due to the heating or the tacking. The torch is held at approximately 80 degrees. The welding temperature varies between 6,000 and 15,000 degrees Celsius, depending on the capacity of the machine and gas covering. Filler wire is fed into the weld pool either directly or by sliding it along the surface, but avoiding the electrode. The pool is melted, allowed to grow, and filler added as required to build it up. The filler is withdrawn, but not out of the gas shield. The inert shielding gas argon prevents contamination. Having a mixture of argon and helium allows the temperature of the arc to be increased, enabling the welding of thicker pieces of stainless steel, copper and aluminium, which absorb heat very quickly. When finishing at the end of the bead, the crater is filled in to prevent weakness or cracking at this point. TIG welding is slower than the MIG process, but the weld is cosmetically better and of a higher quality. It is used in many industries: food processing, automotive and aircraft. It can also be used in repair work. This corroded oil pump from a boat first needs the corrosion ground off. Then a TIG welding machine is used with an aluminium filler rod to build up the metal surface. This involves laying down a series of welds until the surface is fully covered. Once this is completed, it is machined down and new screw holes are sunk into the metal. The different ways of joining metals, either fusion or non-fusion, provide alternatives for different applications. The method used will depend on the requirement for a particular job.